about it. Okay, question number 1. It says, and by the way, all those are the answers. Just that way we can just verify, right? It says cosine pi x minus 1 equals 0. So how do you tackle this? You tackle this by moving the 1 to the other side. And then you're going to go cosine pi x equals 1. And then I'm trying to solve for x by itself. So what's the next move? Yeah, the inverse. So pi x equals, and you can put plus minus if you want. I'm going to put arc cosine of 1 plus 2 pi n. And then on the unit circle, cosine is only 1 in one location. That location right there. That location is what radian? 0. So right, pi x equals 0 plus 2 pi n. And then I divide everything by pi. Divide by pi, divide by pi, divide by pi. You can also say times 1 over pi. It's the same thing. X equals 0 plus pi n. And then it says to give me all the answers between 0 and 2. So the only answer is 0, because if I had pi, pi is approximately 3.14. You can round it down to 3 if you want. And if I add 3 to that, I would be outside of that domain, 0 to 2. So that's my only answer, and check mark. We got it. Did that make sense, guys? Okay, and I'm going slow. I'll go even slower if you want me to. All right, question 2. So check it out. I'm going to go slow. So how do I tackle this? First, I move the what? The negative 3, yeah. So I'm going to have square root of 3, cotangent pi x equals 3. And then the next move is divide by, perfect. So I have cotangent pi x equals 3 over square root of 3. I would probably do a rational here, or rationalize it. So multiply it by the square root of 3 over the square root of 3. And here's what you get. Cotangent pi x equals 3 square root of 3 over 3. The 3's cancel out, and you just get square root of 3. And I'm going to slow down. The only way to get square root of 3 as an answer is if I have square root of 3 over 2 in the numerator and a half in the denominator, or if I have negative square root of 3 over 2 in the numerator and negative half in the denominator. Cool or not cool? That's the only way. So I need, let's see, cotangent is x divided by y. I need the x to be a square root of 3 over 2, and I need the y to be a half. On the unit circle, that happens at what radian? Pi over 6, perfect. So I'm going to go ahead and write it right here. Where do I write it? I'm going to write it right here. And pi over 6 plus pi, by the way, because cotangent repeats every pi. So I'm going to write pi x equals, I guess let me write the whole steps. Arc cotangent of square root of 3, and then you put plus pi n. Cotangent and tangent just have one equation. The plus pi will get you the other one, the 7 pi over 6. So that we said was pi over 6. Pi x equals pi over 6 plus pi n. And then the last thing I do, I have a pi there. You can either divide by pi. I notice that some of you like to multiply by the reciprocal. That's fine. Multiply by the reciprocal. 1 over pi, 1 over pi. That's the same thing as dividing by pi. So I'm going to have x equals, the pi's cancel out, and you get 1/6, and the pi's cancel out, plus 1n. Here's my equation. Trav, how do I get the answers? I want all the answers between 0 and 2. So one answer is 1/6, and another answer is 1/6 plus 1. Relax, turn that 1 into 6 over 6. What's 6 plus 1? And there's that 7/6. See? If I add another 1, it would be outside the domain because you just added already 2. Does that make sense? See? So that n just means like n is a whole number. It's how many, like how often, well, once the 1 is a period. So the n is how many periods have you gone? How many cycles have you gone? That's all it means. I could also go backwards. I could have gone negative, but the domain is not part, the negative is not part of it. So there it is. Cool or not cool, guys? Did all that make sense? Okay. Let's go to question 3. So I have this expression here. So I don't have anything in front of the cosine, so I'm going to get rid of the cosine by doing the inverse cosine. You can put plus or minus if you want. Arc cosine is 0 plus 2 pi n. The reason I'm not putting plus minus in the front is because these are all perfect coordinates. On the unit circle, cosine is 0 in 2 locations. Where and where? Perfect. So I'm going to write 1/3 x1 to indicate my first one equals pi over 2 plus 2 pi n. And then I'm going to put the other one right here. 1/3 x2 equals 3 pi over 2 plus 2 pi n. And I'll zoom in. Now the last thing I do is just multiply everything by 3. See? Times 3 times 3. Everything you do to one side, you do to the other. So here's what I have. I have x1 equals, if I multiply by 3, I get 3 pi over 2 plus 6 pi n on that one. Let's see what I get on the other one. x2 equals, I multiply by 3. 3 times 3 is 9. So 9 pi over 2 plus 6 pi n. All right, I look at my domain. Let me zoom out. 0 to 6 pi. So you're not going to add a 6 pi because that's already at the threshold. If I add 6 pi to this positive, I'm going to be outside of that domain. Does that make sense? So my only answers are 3 pi over 2 and 9 pi over 2. Oh, look at that. 9 pi over 2 and 3 pi over 2. Those are the answers. I put it to give me the answer key. How do we feel? Does that make sense? Okay. Am I going too fast or am I going at an okay speed? Okay. All right. Yeah, I'm trying not to go too fast, guys. I listen to you guys. I listen. If you guys tell me that, oh, he's go too fast. Okay, I'm trying my hardest to go a little slower. Okay. So here we go. I have square root of 3 cosecant pi over 2x equals 2. I got to get rid of the square root of 3, so I do that by dividing. So I have cosecant of pi over 2x equals 2 over square root of 3. You can solve it like that if you want, but I think it's easier to do the reciprocal of cosecant. What's the reciprocal of cosecant? Sine. So leave the argument alone. That's a pi over 2x. So you're going to write sine and leave the pi over 2x alone equals square root of 3 over 2. Are we okay so far with that? Okay, next I'm going to do the inverse of sine. So I'm going to write pi over 2x equals arc sine, or sine to the negative 1, of square root of 3 over 2. And I put plus 2 pi n. Have I done anything crazy? Nope. And then I'm going to write a unit circle right here, so you guys can see the visual for you visual learners. And I know that sine is square root of 3 over 2 at there and there, in quadrant 1 and quadrant 2. What is that radian? Pi over 3, that's the first one. And the other one is 2 pi over 3. So here we go. I'm going to write pi over 2 x1, because there's 2 of them, equals pi over 3 plus 2 pi n. And then let me change the color so it's easier to see the second equation. I'm going to write it right here. I'm going to write pi over 2 x2 equals 2 pi over 3 plus 2 pi n. I'm going to solve the red one first. So I'm going to multiply by 2 over pi. Whatever you do to one side, you do to the other. And I'm going to do the same thing in the other one, but I'm going to go ahead and continue this one first. x1 equals, let's see, the pi's cancel out, so I'm going to have 2/3 plus, let's see, the pi's cancel out, 2 times 2 is 4. And I put a little n. And don't worry, we'll come right now to it. That's a 3 in the bottom. 2 over 3. Let me put sky blue here, or times 2 over pi times 2 over pi. So we're going to get, or purple here, x2 equals, let's see, pi's cancel out, 2 times 2 is 4, so 4 over 3 plus 4n. All right, let's see, what's my domain? Between 0 and 4. So 4 is already at the edge. Remember, that's a period, so I got to keep adding 4 to it. But I'm not going to add 4, because if I add 4, it's going to take me outside the domain. So my answers are 2/3 and 4/3. And look, there it is, 2/3 and 4/3. Cool or not cool? Is all this making sense? Okay. I'm going to choose a different color here because I don't want you guys to get confused with all this red stuff here. So question 5. I don't have anything in front of the sign, so I'm going to do just inverse sine right off the bat. So I'm going to write 1/2 x equals arc sine of 0 plus 2 pi n. I look at my unit circle. Sine is 0 at these coordinates right there. 0 and pi. So that's what I'm going to write. So here we go. 1/2 x1 equals 0 plus 2 pi n. And I'm going to write another one. 1/2 x2 equals pi plus 2 pi n. So catch up to there. Bless you, bless you. Oh, that was a cough, sorry. I'm going to go ahead and get rid of the half by multiplying by whatever you do to one side, you do to the other. So here we go. I'm going to have x1 equals 0 plus 4 pi n. And I'm going to go to the one in red. Multiply that by 2. Multiply this by 2. And we're going to have, let's see, what are we going to have? x2 equals 2 pi plus 4 pi n. Are we okay so far? All right, so let's see what my answers are. My answers are just going to be 0. Let me tell you why. 2 pi is larger than 3, because imagine pi like 3. 2 times 3 is 6. It's already outside the domain. Do you guys see that? And if I add 4 pi, that's just going to give me negative 2 pi. And negative 2 pi is also outside the domain, because that's like negative 6. So the only answer is 0. How do we feel? Okay, let's go to the next one. Oh, this one has a lot of answers. So let me change to burnt orange. Okay, here we go. You had this exact one? Okay, check it out. You're gonna love it. I'm gonna divide by square root of 3, both sides. So I'm gonna have cotangent 1/2 x equals negative 3 over square root of 3. We don't recognize what negative 3 over square root of 3 is, so I'm gonna rationalize it. And we figure out that that is negative 3 square root of 3 over 3 stretched out. So the negative square root of 3. And I'm going to write it up here. The only way you can get a negative square root of 3 is if you have a negative square root of 3 over 2 in the numerator and a positive half in the denominator, or a positive square root of 3 over 2 in the numerator and a negative half in the denominator. That's the only way, because the 2's cancel out and you get negative square root of 3. So I'm looking at this first one here. That happens in quadrant 2. And this is cotangent, so it's x divided by y. So where does that happen at? Well, it happens in quadrant 2. What radian? Oh, cotangent, not cosine. Yeah, you be brave, guys. I'm sure you guys will get it right. Not pi. Oh yeah, pi over 6. Yeah, good job. You only need one equation for cotangent, because if you add pi, yeah, sorry, miss. If you add pi, you'll get the other answer, which is 11 pi over 6. Do you guys see that? No? Okay. I'll do the unit circle so you can see it. I said 5 pi over 6. Initially, I heard pi over 6, but then you said 5 pi over 6, right? Yeah. Check it out. No, I heard you. Did you say 5 pi over 6 or pi over 6? Yeah, I heard you, miss. 5 pi. So 5 pi over 6 is here, and if you add pi, you'll be over here at 11 pi over 6. See? So you just need one equation. So here we go. I'm going to write 1/2 x equals 5 pi over 6 plus pi n. And then I got to multiply by 2. So I'm going to go times 2 times 2. So let's see what my equation is. X equals 2 goes into 6 3 times, so I get 5 pi over 3 plus 2 pi n. Notice it says from 0 to 9 pi, so that means you can probably do 3 iterations or 4 iterations. Chav, what are you talking about? If n equals 4, 2 pi times 4, that's only 8 pi. And 8 pi is still smaller than 9 pi. Do you guys see that? So that means I can go n equals 1, n equals 2, n equals 3, n equals 4. Maybe n equals 4. Actually, no. Because if I go extra n equals 4, I think I'm going to be above the 8 pi or the 9 pi. We'll check it out right now. So one answer is 5 pi over 3. So I'm going to write, I'll put it right here in this header here. X equals 5 pi over 3. Another answer, add 2 pi to that. So I'm going to turn that, Chav, how do you do it then? I'm going to turn that into, I'll just multiply by 3. 6 pi over 3. Look, 6 divided by 3 is still 2 pi. So 6 plus 5. There's 11 pi over 3, comma. Now, what's 11 plus 6? There's 17. Oh, hold on. Did I get it right? Yeah, 17 pi over 3. And then what is 17 pi over 3 plus another 6 pi over 3? 23 pi over 3. You know what? I'm going to do one more just for kicks so you guys can see, like, Chaba, how do I know to stop there? Let's say I keep going. What's 23 pi over 6 plus 6 pi over 3? 29 pi over 3. Okay. How do you know when to stop? Okay, here's how you know. Check it out, guys. I need you guys to focus so you guys can start understanding number theory. Focus on this. You see the 29 over 3, guys? All right, focus real quick, guys. I know that this number is bigger than 9. Chow, how do you know that? I know 27 divided by 3 is 9. Do you guys know that? All right, well, look, is 29 bigger than 27? So then this number, if I put the pi in, that's bigger than 9 pi. Do you see how we did it? Cool or not cool? Cool. Okay, now we're getting to the hard ones here. These are the hardest they get. These are from level 3. All these have been level 3, really. Look at all this beautiful math. Does your paper look like this paper? Doesn't that look beautiful? In many ways, it looks like art, guys. Okay. Yeah, show it to Martinez. So she can be, look at all this beautiful art. All right. Hey, Martinez, if you're watching my YouTube channel. Okay. Here we go. Move the 1 to the other side. Move the 1, guys. Focus. 2 sine 2x equals 1. And we have a lot of space on this one, so you can write all on the right side if you want. All right. What is the next move? Divide by 2. So I'm going to write sine 2x equals a half. What is the next move? Inverse. So I'm going to write 2x equals arc sine of half plus 2 pi n. And the only reason why I haven't been doing two formulas, the pi minus arc sine, is because these are perfect radians, or perfect coordinates. And radians, I guess you can say. All right, on the unit circle, I'm going to draw it right here. Yeah, the unit circle doesn't go away, so if you can have the unit circle with you. Where is sine a half? It happens in quadrant 1 and in quadrant 2. That's one of them. What's the other one? Perfect. 2x1 equals pi over 6 plus 2 pi n. And then I'm going to move over here, and I'm going to write the other one. 2x2 equals 5 pi over 6 plus 2 pi n. Are we still okay, guys? All right. I come back to the first equation, and I want to get rid of that 2. I can either divide by 2 or multiply by half. It doesn't matter to me. You guys have been liking to multiply, so I'm just going to multiply by half, because that's what you guys have been liking. And here's what I get. I get x1 equals, let's see, pi over 12 plus pi n. Now I'm going to go to x2. I'm going to do the same thing. I'm going to multiply by half. I'm going to multiply this by half. And here's what I get. x2 equals 5 pi over 12 plus pi n. Are we still okay? All right. It wants all the answer between negative pi and pi. So that means this is an answer, pi over 12. This is an answer, 5 pi over 12. But I can also go to the left. So how do I go to the left? By subtracting. So I'm going to subtract. So here we go with my subtraction. Pi over 12 minus, and I'm just going to put a 12. 12 pi over 12. That's 1 pi. So pi minus 12, that is negative 11 pi over 12. And that is between negative pi and pi, because it's 11/12 of a pi, but in the negative direction. Are we okay so far? I'm going to do the same thing with the one over here, guys. So I'm going to go over here. I'm going to write 5 pi over 12 minus 12 pi n over 12. Actually, remove the n because n is 1 right there, or negative 1. 5 minus 12, what's that? So negative 7 pi over 12. That is between negative pi and pi, because 7/12 of pi is less than a whole pi. But in the negative direction, obviously, because it's negative 7 pi over 12. So my answers are, let's see, what are my answers? Pi over 12, that's one of them. 5 pi over 12, that's another one. Negative 11 pi over 12, and negative 7 pi over 12. Yes, ask.
How do you get to add or subtract, like, you did pi over 12 minus 12 pi over 12?
Yeah.
I didn't really subtract or add.
Awesome question, Martinez. So check it out. See how it says domain here between negative pi and pi? I would have never subtracted if I didn't see that domain. If it said 0 between 0 and pi, I'm not going to subtract because it's not part of my domain. But as soon as you see that your domain goes to the left of 0, as soon as you see that your domain is negative, like, oh, I wonder if I subtract, if I'm inside there. Do you see what I mean? Yeah, so you look at it and you're like, oh, the domain's between negative pi and pi. These answers are positive. I can be negative. Oh, let me subtract. Like,
it's like whenever the other side has a negative.
yes, when you see a negative in the domain, be like, I wonder if I go backwards, if I get an answer that's going to be within, and then you go back. Did I answer your question?
Yeah.
Are you satisfied? Okay. Ask.
Why do we use 12 over 12?
Oh, because my denominator is 12, and I still want to add pi. So if I put 12 pi over 12, that's still pi, miss. Look, 12 over 12 is 1. So I'm just adding and subtracting pi. So I just did to answer your question quickly. Common denominator. I need to get a common denominator to add and subtract. Now, ask me some more questions, guys. I can't read your minds. Ask. This is good. I like this. All right. Let's go to the last one, guys, and then we'll set you guys free, and then I'll let you guys know for those that are already done with the delta what you can work on next. All right. Square root of 3 cotangent 3x minus 1 equals 0. Move the 1. So square root of 3 cotangent 3x equals 1. Divide by square root of 3. So cotangent 3x equals 1 over square root of 3. And I'm going to stop here because the only way this will happen, is if you have a half in the numerator and a square root of 3 over 2 in the denominator, or a negative half in the numerator and a negative square root of 3 over 2 in the denominator. All I got to do is focus on this equation, on that one, because if I add pi, I'll get the other one. So I'm going to do inverse. So I'm going to write 3x equals arc cotangent of 1 over square root of 3, and I'm going to put plus pi n. The arctan and arccotangent have plus pi n. On the unit circle, remember this is cotangent, so I want that to be an x. Where is x a half and y a square root of 3 over 2? Pi over, not pi over 6.
Oh, pi over 3.
Pi over 3. That's where x is a half and the y is square root of 3 over 2. Yeah, the unit circle doesn't go away, guys. So I'm going to write 3x. This one doesn't require two equations. You can just do it in one. Equals pi over 3. Ooh, someone had a boo-boo. Plus pi n. Are we still okay? Okay. Next, I get rid of that 3 by what? Multiply by 1/3. You can also say divide by 3. It's all the same, but you guys like multiplying, so multiplying by 1/3. When you do that, you're going to get x equals, let's see, pi over 9 plus pi over 3n. Cool or not cool? Check it out, Martinez. Am I going to subtract? Look at my domain, 0 to 4. Yeah, there's no reason to. You can only move forward. So on this one, pi over 9 is one answer, and they want all the answers between 0 and 4. So I'm going to go to the side. I'm going to go, okay, so check it out. Ready, Cepeda? That 3, I'm going to turn it to a 9. And I do that by going times 3 over 3. And I did that because of the common denominator. So I'm going to write it right here. I'm going to write x equals pi over 9 plus 3 pi over 9. So I do that first. What's 3 pi plus pi? 4 pi over 9. And then I think, is this smaller than 4? Well, yeah, 4/9 of pi is still smaller than pi, and pi is about 3.14. So 4/9 of pi is a smaller number than 4. So that's an answer. And then I take the 4 pi over 9, and I'm going to go, okay, let's see if I have another answer. 4 pi over 9, and I keep adding the period, which is pi over 3, plus 3 pi over 9. Yeah, 4 plus 3 is 7, 7 pi over 9. And I ask, is that smaller than 4? It is, because 7/9 of pi is smaller than 3. So I keep adding. So I take that 7 pi over 9, and I go 7 pi over 9, and I keep adding 3 pi over 9. So let's see, 7 plus 3, that's 10 pi. 10 pi over 9. That's a little smaller, a little bigger than 3, because it's a little bigger than a whole pi. Do you guys see that? And that's probably going to be it, but just for kicks, let's see if we would have done it, if we would have kept going. Let's see what would have happened. 10 pi over 9, let's see if it's obvious. Plus 3 pi over 9 equals 10 plus 3, 13 pi over 9. Look how obvious it is. It is. It's obvious. It cannot be this. Chop, I can't tell if it's bigger or larger than 4. Well, look at this rate. Well, okay, I guess, no, maybe it's not so obvious. Well, let's see. 9 goes into 13 one time, and what's my remainder? 4, 9, so that's 1 4/9 of pi. Oh yeah, that's gonna be cutting it close. 1 4/9. Okay, I know how we can do it. I think. So 4/9 of pi. That's almost 1.5 pi. That's almost. So if I take 3 and I multiply it by 1.5, isn't that larger than 4? There it is. So if I take 3 and I multiply it by 1.5, that's larger than 4. So I know this is going to be larger than 4. Cool or not cool? Worst case scenario, just type 13 pi over 9 in your calculator. Look, you can just go in your calculator and go, don't worry guys, we'll finish. We're pretty much already done. I just want to show you. Worst case scenario, you can just take your calculator and you can go, if 4.5? Yeah, so you can go 13 pi over 9, and you'll get what she said, 4.53. It's out. It's way bigger than 4, so they're done with that one. Cool or not cool? Okay, now I know some of you are done with delta, because I saw that there's several of you that already finished. The next assignment that I'm going to add when we come back on the next session, if you want to start ahead, it's called Solving Trig Equations on UH. You know how to do all of them except for one. You only need this rule. So I'm going to give you that rule. You're going to see one of them that says sine 2x equals something, equals, I don't know, some number. Whenever you see sine 2x, replace sine 2x with 2 sine x cosine x. So write that down, and that's the only thing you need to know. Yeah, for those that are doing the UH trig that already got your 100s. So that's it, guys. So if you're done with delta, work on UH. It's called Solving Trig Equations, and see what grade you get. Maybe I'll use yours as an example on Friday.